Well, hello there, folks. Pre-algebra 12.2, talking about angles and parallel lines today. So the first thing we'll talk about is what's called a transversal. So a transversal is a line that intersects two or more lines at different points, okay? So if we had a line there, and a line there, and then we had another line coming through like that. And I said, which one's the transversal? What would you tell me? Well, hopefully you would say it's the green one. Why? Because that green one is a line that intersects two or more lines at different points, right? So it's intersecting the black line there, intersecting the blue line there. The green line is the transversal. And as you can see, when I drew that green line, what it created was 1, 2, 3, 4, 5, 6, 7, 8 angles. Okay, now if we had let's add another line in there. Okay, then that transversal has now created 8, 9, 10, 11, 12 angles. Okay, so that's the transversal. All right, so now let's talk about corresponding angles. Okay, what are they? Well, they're angles that occupy corresponding positions. Okay, so when I say corresponding positions, here's what I want you to think. I want you to look at the transversal. Okay, in this case, it would be this one. Why? Because this is the line that's crossing through two or more lines. In this case, it's only two, but there we go. There's the transversal highlighted. Okay, so what are the corresponding angles? Well, they're going to be the angles that are in the same relative position to the transversal. Okay, so let's talk about this right here. Let's pick one of the angles. I'm going to pick angle 1. Okay, so we're going to say that angle 1 is corresponds to angle 5. Okay, now here's why. If you look at the transversal, when it cuts through this line, angle 1 is to the, top left position, or if you want to use directions, it's to the northwest, right? So when the transversal cuts through this line right here, 5 is also to the upper left, okay? So what are some other corresponding angles? Well, angle 2 is going to correspond to who? Well, angle 6, all right? And angle 3 is going to correspond to who? Well, angle 7. And then lastly, angle, do a different color. Angle 4 is going to correspond to who? Angle 8. Oops, angle 4, angle 8. There you go. All right, so next let's talk about alternate interior angles, okay? So they are two angles that lie between the two lines on the opposite side of the transversal. So that's kind of a mouthful. So let's just think about it in terms of this, okay? Alternate interior angle. So, well, alternate means kind of, well, what? Well, let's think. Kind of like one and then the other, right? Alternate, so different, a different way of doing things, an alternate way of doing things, okay? So they're different, but they're also interior, so different interior angles. That's interesting. So if I were to say which of these angles could not be alternate interior angles, we could automatically wipe out the 1 and the 2 and 7 and 8, right? Those are not interior. So we're only talking about 3, 4, 5, and 6. So angle 3, who is his alternate interior angle? Well, think alternate's going to be like the other way, so it's going to be on the other side of the transversal, and it's going to be an interior angle. So 6. All right, so alternate interior angle. So angles 3 and angle 6 are alternate interior angles. So then you could probably deduce that angle 4 and angle 5 are also alternate interior angles. All right, so we talked about alternate interior, so now we're going to talk about alternate exterior, okay? So again, alternate means different or opposite, okay? And exterior obviously means outside. So if I were to say what angles could we eliminate from this diagram that could not be alternate exterior angles, well, we'd eliminate all the interior angles, right? So we can't be talking about 3, 4, 5, or 6. We're only talking about 1, 2, 7, and 8. So if I said what angle is the alternate exterior angle to angle 1? What do you think? Well, it's going to be, let's see, two angles that lie outside the two lines. Okay, so it's going to have to be outside the two lines. We know that. On opposite sides of the transversal. Okay. So is it going to be angle 2? No, it's actually going to be angle 8. Okay? And then if I said, what's the alternate exterior angle to angle 2? Well, you'd probably say, hey, it have to be angle 7. All right? All right, so now we're going to apply this. What I've done is taken a picture of the John Hancock building in Chicago. And if you look at the architecture of it, we have some lines that and some transversals, right? So the red lines are transversal there, and we have a green line and a blue line. And I labeled some of the angles that are formed there, actually all the angles that are formed. So what I want you to do is I want you to classify these pairs of angles. So we have angles 1 and 8, 2 and 6, and 4 and 5. And so I want you to look in here, and so you probably need to kind of go back in the video and keep looking back and forth, or just write these down real quick, and you can freeze on this and go ahead and classify those angle pairs. Okay, so hopefully you paused the video and did that. Let's see, angles 1 and angle 8. Let's look at those two. Angle 1 right there, and angle 8. Well, let's see, angle 1 and 8. Well, they're both on the outside, and they're on opposite sides of the transversal. 1 is above the red transversal, 8 is below, so they are what? Well, they're going to be alternate exterior angles. So now let's talk about angles 2 and 6. Well, let's see, angle 2 is there and 6 is there. So one's kind of on the inside, right, in between these two lines. The other one's on the outside. So one's inside, one's outside. So I know it's not interior or exterior, okay? But they are what? They are corresponding angles. And why is that? Because they're in the same relative position to the transversal, right? 2 is to the top right of the transversal. 6 is also to the top right of the transversal. So we call them corresponding angles. C-O-R-E-S-P-O-N, angles. All right, and then lastly, 4 and 5. Let's look in here, angles 4 and 5. Well, let's see. 5 is above the transversal, 4 is below, okay? And let's see, they're both inside, right? They're not out here, they're both inside or in between these green and blue lines. So they are interior, alternate interior angles. Alternate interior angles. All right, so now let's talk about parallel lines. Okay, parallel lines help us do something really cool. Now, what two lines do you think are parallel here? Well, hopefully you said the red line and the black line. So we use this little marker here. It's like a little triangle to denote that those two lines are parallel to each other. Okay, so they're parallel lines. So let's talk about the corresponding angles again. In this example, what are the corresponding angles? Well, let's see. Let's start with 1. Okay, angle 1 corresponds to who? Well, angle 5, right? So we'd say angle 1 and angle 5. But when it comes to parallel lines, okay, we have two parallel lines that are cut by a transversal, or intersected by a transversal. Angle 1 and angle 5 aren't just corresponding. Angle 1 equals angle 5. Okay, so corresponding angles when we're talking about not a shape here, but a series of lines and segments, arrays, and there's a transversal that cuts parallel lines. Corresponding angles are not just corresponding; they are the same. Okay, so what do you think angle 6 is the same as? Well, we know that angle 6 and angle 2 are corresponding, but since these two lines right here are parallel, we would say angle 6 actually equals angle 2. Okay? Now, let's talk about, I'll try and get it all on here. All right, so let's talk about alternate interior angles. So if I were looking at this again, what would be my alternate interior angles? Well, let's see. Angle 3 is an interior angle. All right, and he's an alternate interior angle to whom? Well, angle 6, right? So angle 6. But when we have parallel lines, guess what? Angle 3 not only is the alternate interior angle to angle 6, but it also equals angle 6. They have the same exact measure. Okay, and you could also then probably deduce that, you know what, angles 5 and 4, those are alternate interior angles, and they're also going to have the same measure. Okay, they are congruent angles. All right, so now we'll talk about alternate exterior angles. Okay, so let's look at angle 7. Right? Who is the alternate exterior angle to angle 7? Well, that would actually be, so it's got to be on the other side of the transversal and an exterior angle, so that leaves us with angle 2. So angle 7 and angle 2 are alternate exterior angles. But because the two lines that are cut by the transversal are parallel, angle 7 also equals angle 2. They're the same. And you know what? Angle 8, the alternate exterior angle to angle 8 is angle 1. But because it's a parallel, or we have two parallel lines here, they are actually the same exact measure. So that's why parallel lines are special, okay? Because they let us equate angles really quickly. All right, so this last one we're going to do is we're actually just going to solve for x, okay? So I've only given us two angles here, and these two lines are what? Well, they're parallel. Why is that? Because the little parallel lines, parallel marks on these lines, okay? So we're solving for x. Well, I mean, the x is right there. How does anything we have help us? Well, that's the thing. The two angles that we have some data for, okay, are this one and this one. Now, what are those angles in relation to each other? Well, they are alternate interior angles, right? Alternate interior. So, because these lines are parallel, we know that alternate interior angles are equal to each other. So what does that mean? Well, that means that this angle, which is 72, is going to equal this angle, which is 4x minus 4. Right? Now, can we solve for x? Yeah, absolutely, because we have an equation. So I'm going to add 4 to both sides. And that's going to leave me with 76 equals 4x minus 4 plus 4 cancels or becomes 0. Now lastly, I'm going to divide by 4 and divide by 4. And let's see. Those cancel there. X equals 76 divided by 4. Guess what? That gets you 19. So, what is x? X is 19. How do we solve that? Because parallel lines, the alternate interior angles formed by parallel lines and a transversal are equal. They are the same, and that helped us find x. So it's actually 19, so 72 degrees, and this would also then be what? Well, that angle has to be the same as that, so it's 17 degrees. Can we check? Yeah. Let's plug that 17 in there for x. So I'm going to rewrite this as 4 times, did I say 17? 19. 4 times 19 minus 4. Well, let's see. 4 times 19 gets you 76, right? So that right there is 76 minus 4. That equals 72. So this whole angle there is 72. That angle is 72. We checked our work. We did it right. And that is all I have for you on this video, guys. I look forward to seeing you in class. We talk more about angles. See ya.